How did a routine update to an endpoint security sensor end up crashing millions of computers worldwide? Today, in this video, we're going to dive into the cybersecurity industry and one of its biggest failures. And we're also going to replicate planning a security sensor on our ArtusAI tool. So before we get started, let's talk a little about Crowdstrike. Crowdstrike makes a product called Falcon, which is used by some of the largest organizations in the world: airlines, hospitals, banks, and government offices. It works by installing a small program on every computer in the company, which quietly watches the computer all day and all night, looking for signs of hackers or dangerous behavior. On July 19, 2024, Crowdstrike released a normal Falcon update, which was meant to improve protection. Inside the update was a kind of checklist. Look at these things. If you see them, react. This kind of update happens many times a day. Companies allow it because they trust Crowdstrike to keep them safe. The problem was small, almost silly. The checklist asked Falcon software to look at 21 things, but the Falcon software running on computers only had 20 things available. During testing, the missing item existed on paper, but the software never actually had to examine it closely. But then the update reached the real world, and for the first time, Falcon actually tried to look at the 21st thing. And when it did, it broke. Some computers were stuck in endless restart loops. Some couldn't fix themselves at all. Rolling back the update didn't help, because fixing the computers now meant manual help, one by one. Flights were delayed, hospital appointments were postponed, payments slowed. Customer support systems went dark. But what actually went wrong in this case wasn't the execution. It was the lack of proper planning and testing. So let's try to plan a similar software and understand how Crowdstrike's planning could have avoided this slip-up during their discovery phase. Firstly, I go into Artus. I select a B2B audience and then expand on my vision of wanting to build an endpoint security sensor with all its failure paths designed. The AI agents ask me which agendas I want to include in my software, and on top of all the ones that it has already recommended, I choose Threat Intelligence Integration. But for the purpose of this video, let's focus on just two modules: Update and Deployment Manager and Safety and Control module. Let's begin with the Update module. I select some options like logging all update deployment activities and scheduling updates in predefined intervals. Once I'm done choosing features, I head to the chat to brainstorm recovery designs with the analyst. Firstly, I ask, what if the update ends up crashing a computer? What is the testing mechanism, recovery design, and other methods to avoid mistakes at a global scale? The analyst gives me different tiers of solutions, like the simplest one, which is testing the update in a lab, deploying to all, and rollback if crash is detected, which is exactly what Crowdstrike did. The complexity of implementing this solution is the lowest. However, the one I decide to go with is the standard tier, which includes deploying the update to a small canary group first, automated checks for computer compatibility, monitoring for crash signals, and immediately stopping further update rollouts if crash is detected in few computers of the canary group. The complexity of implementing this feature is moderate and will take years, but our main priority is safety at all costs. So I tell the analyst to draft the detailed flows and requirements of the standard plan. As a precaution, I also ask the analyst what our recovery design options are in case of system breakdown or other rare failure scenarios. And the analyst gives me a comprehensive list of both rare failure scenarios and their recovery paths. I implement this module and ask the system for both the interface of the central control system and the business requirements. Similarly, I choose recommended features for the safety module and then brainstorm questions with the analyst. Most importantly, I ask what happens if the central control system goes down. What will be the backup plan? In order to avoid suspicious behavior in large organizations that are depending upon our software, since we want this system to take many years to build so that it is completely failure-proof and recovery design, I choose option 3, which includes the computers autonomously running security checks, coordinating with their peers in case of attacks, and using a cloud fallback service for backing up data. This will be highly complex to implement, and I will need a multi-agent technology to make it happen. Once I'm done planning every agenda, the AI architect gives me a broad system overview of the critical success factors of the software, an execution timeline, a recommended technology stack for execution, and also the variety of expertise team members needed to bring this idea to life. It also gives me feature and business requirements for each and every feature I selected in detail, so that I can start executing immediately with a precise direction and end goal in mind. The visual prototypes further give me a better idea of how the dashboards will look if the routine updates seem healthy or if they end up negatively affecting the computers. I can easily detect crash signals and stop rollout instantly, without confusion. Now here's the part that matters. Even if you don't build cybersecurity software, every modern product has a Crowdstrike moment waiting inside it. If your AI explains prices or policies, your updates deploy automatically, your users can't opt out, your system acts faster than humans can react, then you're already operating at blast radius scale. The lesson isn't write better code. It's this: plan as if mistakes will escape, design as if recovery will be slower than you want, and treat failure containment as a product feature, not an incident response. That's what ArtusAI is built for, because once the update is live, the planning phase is over, and the outcome is already decided.